Welcome to Basic Science for JSS 3. Today we study simple machines, what they are, how they help us, and how to calculate their efficiency and mechanical advantage. What is a simple machine? A simple machine is a device that makes work easier by changing the magnitude or direction of a force. Simple machines do not reduce the total amount of work done, they change how the work is done, often allowing a smaller force to be applied over a greater distance to achieve the same result. The 6 simple machines are lever, inclined plane, screw, wedge, wheel and axle, pulley. Key terms: effort, E, the force applied to the machine, the force you put in. Load, L, the resistance force the machine overcomes, the force you want to move. Effort distance, D_, the distance through which the effort moves. Load distance, D_, the distance through which the load moves. Mechanical advantage, MO. Mechanical advantage is the factor by which a machine multiplies the force applied to it. MA equals load/effort equals L/E. If MA 1, the machine multiplies force, you apply a small force to move a large load. If MA equals 1, no force multiplication. If MA 1, the machine reduces force but multiplies distance or speed. Velocity ratio, or VR. Velocity ratio, also called ideal mechanical advantage, compares the distance moved by the effort to the distance moved by the load. VR equals effort distance/load distance, equals D_/D_. In an ideal, 100% efficient machine, MA equals VR. Efficiency of a machine. Efficiency tells us how well a machine converts the work input into useful work output. Efficiency equals MA/VR times 100% equals useful work output/total work input times 100%. Real machines are never 100% efficient because of friction, some energy is lost as heat. Efficiency equals load times load distance, /effort times effort distance, times 100%. 6 simple machines. 1. Lever, a rigid bar that rotates about a fulcrum, pivot point. 3 classes. Class 1, fulcrum between effort and load, seesaw, scissors, pliers. Class 2, load between effort and fulcrum, wheelbarrow, nutcracker. Class 3, effort between fulcrum and load, tweezers, fishing rod. MA of lever equals effort arm/load arm. 2. Inclined plane, a sloping surface used to reduce the effort needed to raise an object. VR equals length of slope/height of slope. Example: ramps, roads up hills. 3. Screw, an inclined plane wrapped around a cylinder. Used to convert rotary motion to linear motion. Examples: boats, jar lids, drills. 4. Wedge, 2 inclined planes back to back. Used to split or push apart objects. Examples: axe, knife, chisel, nail. 5. Wheel and axle, a large wheel attached to a smaller axle. Rotating the large wheel turns the small axle with greater force. Examples: steering wheel, doorknob, screwdriver, bicycle gears. VR equals radius of wheel/radius of axle. 6. Pulley, a wheel with a grooved rim. A rope or chain runs over it. Pulleys change the direction of force and can multiply force. Fixed pulley, changes direction, MA equals 1. Movable pulley, multiplies force, MA equals 2. Block and tackle, combination of pulleys, MA equals number of rope segments supporting the load. Example calculation. A machine uses an effort of 200 N to lift a load of 600 N. The effort moves through 3 M while the load moves through 0.8 M. Calculate MA, VR, and efficiency. MA equals load/effort equals 600 divided by 200 is equal to 3. VR equals D_/D_L equals 3 divided by 0.8 is equal to 3.75. Efficiency equals MA/VR times 100% equals March 3rd 75 times 100% equals 80%. Remember, simple machine equals device that makes work easier by changing magnitude or direction of force, does not reduce total work done. 6 simple machines: lever plus inclined plane plus screw plus wedge plus wheel and axle plus pulley. Key terms: effort, E, equals force applied to machine, force you put iron load, L, equals resistance force machine overcomes, force you want to move effort distance, D_E equals distance effort moves, load distance, D_L equals distance load moves. Mechanical advantage, MA, equals factor by which machine multiplies force, MA equals load slash effort equals L slash E, MA 1 equals machine multiplies force, small effort large load, MA 1 equals reduces force but multiplies distance or speed. Velocity ratio, VR, equals ideal mechanical advantage, VR equals effort distance slash load distance equals D_E slash D_L, in ideal machine, 100% efficient MA equals VR. Efficiency, tells how well machine converts work input to useful work output, efficiency surface MA slash VR, times 100% surface useful work output slash total work input, times 100%, real machines never 100% efficient, friction loses energy as heat. Example, effort equals 200 N, load equals 600 N, D_E equals 3 M, D_L equals 0.8 M, MA equals 600 slash 200 equals 3, VR equals 3 slash 0.8 equals 3.75, efficiency surface match toward 75, times 100% equals 80%. Lever, rigid bar rotates about fulcrum, pivot class 1, fulcrum between effort and load, seesaw plus scissors class 2, load between effort and fulcrum, wheelbarrow plus nutcracker class 3, effort between fulcrum and load, tweezers plus fishing rod MA equals effort arm slash load arm. Inclined plane, sloping surface, VR equals length of slope slash height, ramps plus roads. Screw, inclined plane wrapped around cylinder, bolts plus jarlets. Wedge, 2 inclined planes back to back, axe plus knife plus nail. Wheel and axle, large wheel plus smaller axle, VR equals radius of wheel slash radius of axle, steering wheel plus doorknob. Pulley, wheel with grooved rim, fixed, changes direction, MA equals 1, plus movable, multiplies force, MA equals 2, plus block and tackle, combination, MA equals number of rope segments supporting load. Thank you for studying basic science with us today.